Hi and Assalamualaikum. I would like to present to you guys my project title, which is Evaluating the Effectiveness of Mudball for Water Pollution Control in Dishes in Parit Baru and Polytechnic Sultan Idrisshah, Sabak, Bernam. My name is Danisha Kristina Samsu Arifin. My matches number is F1014 F1014.
Hi, my name is Nura Ayala Jamiti Alas and my matches number is F1036.
Water is essential for life and ecosystem balance, but pollution from human activity cause eutrophication. Excessive nutrient like nitrogen and phosphorus lead to algae growth, oxygen loss and death of aquatic life. EM mudball made from clay and beneficially microorganisms offer a simple, cheap and eco-friendly solution by breaking down waste, reducing nutrient and restoring water quality.
Although rural areas are often seen as clean and unpolluted, water pollution in Malaysian villages has become a growing concern, especially due to eutrophication, which happens when water contains too many nutrients. There are three main causes of this problem. First, agricultural activities, where the excessive use of fertilizers and pesticides increases nutrient levels like nitrates and phosphate in waterways. Second, domestic waste from households, such as food scraps, soap and sewage that flows directly into rivers without treatment. This encourages algae growth and reduces oxygen in the water. And third, aquaculture activities like fish or prawn farming, which release organic waste containing ammonia, nitrogen and phosphorus into the water. In short, while rural areas appear clean, these human activities are actually polluting water sources, showing the urgent need for eco-friendly solutions such as EM
Eutrophication stresses affect water bodies and aquatic life. It changes water color, produce odors and reduce water quality due to excessive algae growth. The decomposition process absorbs up oxygen, causing fish death and biodiversity loss. Algae also block sunlight by hindering photosynthesis and some release toxins harmful to humans and animals. Additionally, increased microbial activity can spread waterborne diseases like diarrhea and chlorella, threaten public health and raising
For
treatment
this
costs.
study, we have two main objectives. The first objective is to determine the effectiveness of EM mudballs in improving ditch water quality. This is done by observing changes in turbidity levels over a period of 9 days. In other words, we want to see whether the water becomes clearer after the EM mudballs are applied. The second objective is to measure the changes in ammonia nitrogen levels before and after the EM mudball application. This helps us to understand how effective EM mudballs are in reducing pollutants and improving the overall water quality. Through these two objectives, we aim to evaluate how well EM mudballs work as a natural and eco-friendly solution for treating polluted water. I will explain how the EM mudballs are made. First, we mix topsoil, rice hulls, wakashi and molasses until everything is well combined. Then, we slowly add the EM solution and water little by little until the mixture can be shaped. Next, we roll the mixture into balls about the size of a tennis ball. After that, the balls are placed in a shaded area and left for about 7 to 14 days to allow microorganisms to grow and develop. Once the EM mudballs are fully matured, they can be thrown into drains, ditches, rivers or lakes to help naturally clean and improve the water quality. This simple process makes EM mudballs a low-cost and eco-friendly way to treat polluted water.
You can see from the graph, turbidity level changed over the 9-day period on the 3 location. At beginning, on day 3, turbidity slightly increased at all locations, especially at location 3 with 58% and location 1 with 29%. This happened because when EM mudball were first added, they disturbed the sediment and the bottom and released fine particles, which made the water look clouded. After that, by day 6 and day 9, the turbidity started to decrease gradually, especially at location 1 where it dropped from 39% to 88%, showing the biggest improvement in the water clarity. This decrease happened because the microorganisms inside the EM mudball become active. They started to background the organic waste such as sludge and dirt. As this process continued, the small particles settled at the bottom and the water become clearer. Overall, EM mudball had reduced turbidity naturally by cleaning the water and restoring its balance throughout microbial activity experiment. The ammonia level was high because of the presence of organic and chemical waste in the water. However, after applying the EM mudball, the amount of ammonia gradually dropped at all locations. This happened because the beneficial microorganisms inside the EM mudballs, such as lactic acid bacteria, yeast, and photosynthesis bacteria, begin to break down organic waste and convert ammonia into safer compounds like nitrate through natural biological process. By day 9, we can see big improvement. At location 1, decreased to 99%, location 2, 99.5%, and location 3 completely reached 100 removal. This showed that EM mudball were very effective reducing ammonia nitrogen and improving overall
For the
water
first
quality.
objective, we focus on turbidity, which measures how cloudy or clear the water is. From the graph, we can see that on day 3, turbidity increased at all 3 locations. This happened because when the EM mudballs were first added, they disturbed the sediments and released fine particles into the water, causing it to become cloudier. However, after a few days, the turbidity started to decrease as the microorganisms inside the mudballs began breaking down organic matter. As a result, the particles settled at the bottom, and the water become clearer. By day 9, turbidity had reduced by 35.4% in Pisces Lake, 29.4% in campus drain, and 26.9% in roadside ditches. This shows that EM mudballs were effective in improving water clarity over time. For the second objective, we focus on ammonia nitrogen, which is one of the key indicators of water pollution. At the beginning of the experiment, the ammonia levels were quite high because of the presence of organic and chemical waste in the water. However, after the application of EM mudballs, the level decreased significantly. This happened because the beneficial microorganisms inside the mudballs had break down organic waste and converted ammonia into harmless compounds through natural biological processes. By day 9, the results show a significant reduction. 99% in Pisces Lake, 99.5% in campus drain, and 98.6% in roadside ditches. These findings clearly show that EM mudballs were highly effective in removing ammonia nitrogen and improving the overall water quality.
This study is closely related to SDG 6, which is clean water and sanitation, which highlight the importance of clean water and sustainable sanitation. By using mudball as a simple, low-cost and eco-friendly water treatment method, the study helped reduce pollution and improve the water quality in ditches and lake. It also support SDG 12, which is reversible consumption and production, as mudball use natural materials like clay as a medium to absorb pollution, monollus as food for beneficial microorganisms, and water from the mudball mixture. All these measures are nutrient source and environmental friendly. Finally, the study contribute to SDG 14 life below water by protecting aquatic systems such as river and lakes. Treating water with mudball reduce toxin and excess nutrient, preventing eutrophication and safeguarding aquatic life. This study meet the expectation for our main target group, especially the local community around Parit Baru and Polytechnic Sultan Idris Shah, by helping to improve water quality and the surrounding environment. For education institution, it provide practical learning opportunities for students, connecting classroom theory with real environment application. In addition, this study support community program and environmental NGO through activities such as EM mudball making and natural eco-friendly water treatment effort.
Why and how turbidity happens? EM mudballs contain beneficial microorganisms such as lactic and acid bacteria and photosynthetic bacteria. These microbes help decompose organic matter like decaying leaves, food waste, and sludge in the water. Decomposition and sedimentation, as the organic materials are broken down, fine suspended solid particles become heavier and settle to the bottom, making the water clearer. For reduction of suspended solid, the microbes produce enzymes and organic acids that bind and clump small particles, speeding up sedimentation. And for ecosystem balance, the microorganism stabilize the water's biological condition, reduce algae growth and unpleasant odors, which further improves water quality. So why and how ammonia nitrogen happens? Nitrification process. Beneficial bacteria such as Nitrosomonas and Nitrobacter inside the EM mudballs convert ammonia into nitrite and then into nitrate, which is much less harmful to aquatic life. Second, organic matter breakdown. EM microorganism decompose organic waste, reducing the source of ammonia production. Next is biological competition. The beneficial microbes outcompete harmful bacteria that normally produce ammonia, preventing further accumulation. And next is improved oxygen levels. EM activity increases dissolved oxygen in the water, allowing oxidation process to work more efficiently in converting ammonia.